Hello again. So last time we have seen different time functions and their waveforms. Today we are going to the benefits associated with all those waveforms and what is basically the Laplace transform and its usage for the electric circuit. Okay. So what is basically the Laplace transform? So suppose if you have any quantity in the time domain, you have to find output of it. So you apply it to certain system and from this system you get this output. Okay, so this input can be the voltage. Okay, so input voltage to any circuit. So that circuit consists of some circuit elements, or that is basically the system here, and it gives you certain output which can be any output across any resistor as well. So suppose if that is basically the circuit and you apply this V of t, and across this resistor you have to find out this V naught. So this system will give you this V naught. Okay, so it also consists of many steps in finding out the output, okay, in time domain. Similarly, what if you have to change this V of t? Suppose how many types of V of t do we have? We have recently we have used this DC signals. Similarly, we also used these AC signals as well, and in many applications we have these ramp functions as well. Okay, so in order to test this system for all these signals, what we have to do, the inherent characteristics of all the elements here will also change, as we have also seen in our previous videos. Okay, so in order to do it, we should have here a system where once we will apply some input, it will be multiplied with the internal characteristic of this system and will give us the output. Okay, so in order to do it, we have another transform here, and that is called the Laplace transforms. Okay, so what is basically the Laplace transform? So Laplace transform basically transforms our signal f of t into another domain, which is the S domain, and here we have a signal which is represented by this capital F. Okay, so what are the benefits of the S domain? So in time domain we have many complexities. In order to find the outputs, we have to go through many steps which may involve derivation, integration, convolution. Okay, so all of these steps are basically substituted by the multiplication and division when the signal will be in the S domain. Okay, so in this way it basically removes the complexities associated with all the operations which we have to carry out in the time domain. Okay, so the question is how to transform any signal into the S domain. So it's very easy, because we have to integrate a signal f of t and its product with minus s of t in the time domain, and we have to multiply it, and here we will get their outputs. Okay, so this will be what? This will be the Laplace transform. I am not going into the details of this Laplace transform, and you may find very good videos which will give you the understanding of the mathematical concept associated with converting any of the signal to the Laplace transformed signal. But here we are going to see the applications of the Laplace transforms in electric circuit. So in order to transform it, what we have to do? So suppose I have a resistor here. Okay, in any circuit we have a resistor here, and across it we have, let me have V of t. Okay, and the current it has is I of t. Okay, and the value it has is R. So in order to convert it into the Laplace transform, what we have to do, we have the formula for it, and that is the Ohm's law, and according to the Ohm's law we have V t is equal to I t into R. Okay, so converting this one into the Laplace transformed version, what I will have? I will have V of s equal to the I of s into R. Okay, or from here we can very easily see that R is equal to the V s divided by I of s. So here we can see that in Laplace transform the value of the resistor will remain same. Similarly, in order to see the values of different functions in the Laplace transform, what we can do here, so that is basically the unit step function which has a value 1, okay, throughout. So the value of 1 or u of t which is 1 throughout will have the Laplace transform 1 by s, which you guys can confirm from your tables, okay. Similarly, here this is t, which is basically the ramp function, and that is here is 1 over s square. So this transformation, once you will put this t here and do all the effective steps here, you will get that t is equal to 1 by s square. Similarly, this is sine of omega t, okay, and converting it into the Laplace transform, I will get here omega divided by s square plus omega square, okay. So what does it mean? So if I have these signals, if I have a system here which will have, let me have g of s, and something has been applied here, and that is, let me have, this is input of s and we are going to get output of s. So here this signal can be, this g of s can have any value, and whatever will be applied here, that would be multiplied with g of s will be multiplied with I naught of s, and it will give me what? This will give me O of s. So it can be now this DC signal or this sinusoidal signal or this ramp function as well, because this is now, when this is I naught of s is 1 by s, this is DC signal. Similarly, when that is omega divided by s square plus omega square, this is sinusoidal signal, and when this is 1 over s square, it will give me this one, while the multiplication and other operations will be carried out over this product and will give me O of s, and this O of s can later be transformed into the time domain, which will give me my answer in the time domain as well, okay. So that's it for the uses of the Laplace transform to find the output in any system. And in our next lecture, what we are going to do, we are going to see the applications of it in the electric circuits. Thank you so much, and I will see you soon.